Okay, so like Hayden tried to say, a rectangle is a special parallelogram. So a rectangle is still a parallelogram. So in a rectangle, we still have opposite sides are parallel, opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. But the cool thing is that since it's a rectangle, all four angles are right angles. And because it is a rectangle, not only do the diagonals bisect each other, but the diagonals are congruent. So you need to do something to bring your attention to the diagonals being congruent. Whether you want to circle, highlight, underline, put a star, put an arrow, you need to make sure that you make your eyes draw attention to the diagonals of a rectangle are congruent. Okay? All right. Oh, the best rectangle there is. A basketball court. You're just jealous because your classmates who are on the girls' varsity basketball team are undefeated. Was your team undefeated? Okay. All right.
Oh, yeah.
All right. The coach is making the basketball team run, that sounds familiar, a new drill along the diagonals. BC is 94 feet. And FC is 106.5 feet. Okay. If we have a rectangle, what is the same length as FC? All right. So we know that BD is the same length because our diagonals are congruent. If our diagonals are congruent, they have the same measure, which means BD is also 106.5 feet. Now, if... What?
I drew my 6 like a B, and I realized like they're like 6.
Okay, that's a cool story. Now, since our rectangle is a special parallelogram, what else is true about the diagonals? What else is true besides them being congruent? They bisect each other. So if I ask you for DG, how would we figure that out? Okay, 106.5 cut in half. DG is 53.25. What?
No, but like you never said like
He's still on the beam.
Okay.
But like, look, if it's too far over,
So if you
if
have
it's
one
too
side
far over,
and
it looks
one
wonky.
diagonal, can you find all the other sides?
Yeah, draw it.
Ooh, great question. If you know one side length and one diagonal, can you find, did you get it?
Yep.
Okay, so you're going to show me how to do it later. Okay. Yes. Alex, do you like airheads? Do you like airheads?
Yeah.
Would you like an airhead for a prize? Okay. Alex just solved a puzzle that... yeah, at a different time. Okay. It was an extension of the advisory. Okay. Yeah. And I'm going to circle back to the rectangle. Ha. Okay. Joshua asked, if we know one side and one diagonal, can we find every other measurement? What's the answer? Yes. What would we use? Pythagorean theorem, because we have 4 right angles, we can use Pythagorean theorem to find other things. Okay. Now, another question. Regardless if we know measurements, if it is a rectangle, what do we know about this triangle? What kind of triangle is it going to be? It's always going to be isosceles. What kind of triangle is this going to be? Isosceles. Our diagonals are congruent and bisect each other, so we know that those are all going to be the same measure. Yeah.
And also, this will be future, but if you know one of the angles and a diagonal, you can figure out everything about the rectangle.
Yep. Rectangles are really friendly. They're very friendly because they have 4 right angles. So go to the top of the next page, and can you please solve for these 4 measurements where it says check? Turn it in.
Can you do it?
No. No, I will do it not today. I have conferences. So I'm going to teach all day. Top drawer. I'm going to teach all day. Yeah. I'm going to teach all day, and then I'm going to do conferences. I'm not going to have time to grade. Don't roll your eyes. It's the pink machine over there. Okay, so we know it's an isosceles triangle. All right. Alex Strathman. That's her name, right? Strathman. Isn't that what I said? And it should be.
Strathman.
What is PS? Okay, PS is 7 feet. It's congruent to QR. All right. Ty, what is SQ? I said Ty. Sounds a lot like Austin, I know. Ty?
I think.
How did you get that?
Oh, wait, 7. Wait.
7 and what? 7 and 1/8. Yep. Okay. How did he get 7 and 1/8? Okay. RT is half of the diagonal. So we double it to get the whole diagonal, and diagonals are congruent. Okay. Chase, what is QTR? QTR, that angle right there. So RTS, this guy is 65. And so what do we know about these 2 angles?
Equal to 180.
Okay, they're supplementary. There's your supplementary word, Hayden. So 100 and what do we say? 115. Okay. Now, What kind of triangle is this right here? Isosceles. So if we know that this is 115 degrees and I want TQR, I want this angle right here. How do we get it, Avery? Okay, if this is a triangle, there's 65 degrees left for two equal angles. 65 divided by 2 is?
32.5.
Okay.
I thought it was a right angle, sorry. Couldn't have said 45.
Well, this is a right angle. Did we say anything about the angles being bisected?
No.
No. So we're not going to have 45. We will talk about that, but with a different quadrilateral. Okay? Okay. Now, you are going to have to do some algebra, okay? You might have to work with the diagonals, the sides, or the angles that get cut into two angles that you know make 90 degrees. Or you might have to work with a triangle that's isosceles, okay? So right now, in example 2, BAC, this angle right here is 3x plus 3. ACB, ACB, this guy right here, is 5x minus 1. Okay, well, what do we know about those two? They add up to equal 90, okay? We know that a rectangle has 4 right angles. We also know that opposite sides are congruent. Well, and parallel. So if we have parallel sides, we have, honestly, the way the book is telling you is like, hey, we know that these are alternate interior angles, so this is also 3x plus 3. But you know what I was looking at it as? I was looking at it as, hey, we have a right triangle. Okay, hey, does it matter? No, because either way, we know that these two have to equal 90 degrees. Add up to be 90. We know that they are, what's the word for it? Complementary. We know that 3x plus 3 plus 5x minus 1 needs to add to be 90 degrees. So that means what? 8x minus 2 equal, okay. X equals 11, fine. All right, so how about you figure out the check down below, since you're so good at this. For X? I'm just overhearing that X is 7/4. Some people are agreeing and some people are panicking. X is 7/4. Like 1.75. Did you double MN to set it equal to JL? So do you have 6x plus 2 equals 2x plus 9? So you have 4x equals 7? Yeah, do part B too. What is MK if X is 7/4?
12.5.
If you got 6.25, you found MN, and I would like MK. JK. Did you get 6.25?
It's 184 divided by 8.
It's like
23.
You literally had 4 people tell it to you before you even heard them. You were like, I think it's 20 something. 3 people had already told you. How'd that go for you?
on the wrong side.
No, wait.
Yeah.
Talking about.
How do you guys draw your rectangle?
Don't draw it.
Why are you drawing a rectangle?
It's 8.
Because I can't like see it without.
8x minus 4.
I got 100.
It's like right.
All right.
Oh, okay, that's what I did wrong. I see.
I can give you one, but I don't have any. Second, give one.
That was a different rectangle.
I got a 75.
Because I didn't see like.
What do you need to do with the 2 angles in part B?
Add them together.
I don't know, 180.
Okay, they are supplementary. Tomorrow. So you need have x equals 23?
Yeah.
Okay. Which means J and K is what?
115.
Really?
117.
117, which would make this 63. Okay.
Yep.
I didn't add it too.
I was at 150 if you didn't want to.
I said 115.
I said 150 to 65.
Okay. In example 3, AB is marked as 50 feet. BC is marked as 20. AD is 20. AC is 54. Wait, JK, I said AC? AC is 54. And BD is 54. Did I skip a 50?
No.
No,
The
Yes, I
last
did.
one-
Oh, it does tell you.
Okay. What can we classify this as?
A rectangle.
No, it's not rectangle yet.
It's a parallelogram.
Okay. First of all, because both sets of opposite sides are congruent, we know that it's a parallelogram. However, additionally, Austin, on top of that, since the diagonals are congruent, we can take one step further and call it a rectangle.
Rectangle. Ooh.
Remember my joke? Yeah.
Dude, the joke now is so free.
What joke?
Because it goes on forever.
Yeah. Okay. Now, it was going to be Friday, so now it'll be Tuesday. We're going to talk about in a coordinate plane how to determine if we have like different quadrilaterals. Okay? If I found slope, what would be true about the slope of GH and HJ? Okay, and if they're perpendicular slopes, what would they be? Opposite reciprocals. What would we need to do to figure out if the diagonals were congruent?
Or the Pythagorean theorem.
Distance formula. We would use the distance formula, but we're not going to do that. I mean, you would have to know this distance and this distance, and then you could do the Pythagorean theorem.
Technically,
I mean,
put that in the Greek theorem.
the midpoint would help you with making sure it's a parallelogram. Okay? So here's the deal. Starting on page 433, you need to do 1 through 14, 29, 30, 33, and 34.
5 minutes.
Wait, that's the homework?
Oh wait.
Just flip both at the same time.
You know what?
I got you. But please, I got it. You got the table. Oh, I do have the table. I forgot about that. I'll make it easy.
Okay.